What's going on, guys? Let's look at this problem right here. Here we have a first order linear differential equation, but this is not in a standard form. The standard form of the first order linear differential equation should look like this. We have to have dy over dx plus p of x y is equal to q of x. This is the standard form of a first order linear differential equation. But here we have t, so instead of x we can replace everything with t. Like we can also write it as dy over dt plus p of t y is equal to q of t. Okay, in this case it's going to be like that. Now let's see how we can bring this one in this pattern. Now in order to do that, first I'm going to rearrange something. So first I can bring this dy to the other side. If I do that, this is going to become t plus y plus 1 times dt is equal to dy. Now I can bring this dt to this side, so this is going to become t plus y plus 1 is equal to dy by dt. But if you look at this one, after dy by dt we have to have a function of t multiplying y. Now here we can bring this t to this side in order to bring that, or we can bring this y to this side. Yeah, bringing y to this side would be the correct thing, because that will bring this pattern. So let's go ahead and do that. This is going to be dy over dt minus y is equal to t plus 1. Now here we have this pattern. Okay, now function of t, we don't have that one because we can also consider as t power 0. So here what is p of t? P of t is whatever the value that's multiplying y. In this case it's just -1. Okay, so we can just go ahead and pick up this -1. That's going to be our p of t. Now after we pick up our p of t, the next thing is we have to find out the integrating factor. To find out the integrating factor, we use this equation. Mu is the integrating factor, that is equal to e power integral of p of t dt. This is the equation we have to use in order to find out the integrating factor. In our case, p of t is equal to -1, so we just have to plug p of -1 instead of p of t and calculate the integrating factor. Now let's go ahead and do that. This is going to be e power integral of -1 dt, and if you integrate -1, this is going to be just t, so e power -t, and we don't have to worry about the constant when we find out the integrating factor. Okay, so this is our integrating factor. Now after we find out the integrating factor, we have to multiply the whole thing by the integrating factor. If we do that, this side is going to be dy over dt e power -t minus y e power -t plus t, not plus, equal to, this should be equal to t plus 1 multiplied by e power -t. So this is what we will have after we multiply by the integrating factor. The reason for the integrating factor is when you multiply everything by integrating factor, you can write simple form of this one like d over dt, and I move this y to in front, so y e power minus t. If you find out the derivative of this one, you will get the whole thing back, because this is going to be a product rule. When you do the derivative, you will get the whole thing back. That's the point of the integrating factor. That will make this one simple like this. So we can just equalize this one to the other side. So this is going to be t plus 1 e power -t. Now after we multiply everything by integrating factor and simplify like this, we just have to integrate both sides with respect to t. Okay, now in this side there's no problem because we have derivative and integral at the same time, so it's going to cancel each other. So we will have cancel everything and we will end up with something like this. We will have this part alone. So this is going to be y e power -t remains, and in the other side we have t plus 1 e power -t dt. So we have to do something about this. Here you can see this is integration by parts. If you remember integration by parts equation, when we have integral u dv, we can write this one as uv minus integral v du. Okay, so first we have to pick up our uv values, u dv value. That's the value we have. We have to pick up something as u and something as dv in such a way it can it can be so easy to integrate. Now let's go ahead and pick this one as u, and I'm going to pick this whole thing as dv. So if I do that, let's go ahead and write this one, u, and dv is this one. So u is equal to t plus 1 and dv is equal to e power negative t dt. Now first we have to find out du then, because in this equation we need du. If you find the derivative of this one, that's going to be just 1. So du is just 1. And if we integrate this one, this is going to be negative e power negative t, because e power negative t divided by negative 1, that's going to be negative e power negative t. Now after we find out the integrate like this uv dv, we just have to plug it in this equation, uv minus integration of v du. uv is what? T plus 1 multiplied by this negative e power negative t. So that's going to be negative t plus 1 e power negative t. That's uv minus integral of v du. Integral of v. If you integrate v, you will get this one back like a e power negative t dt. Okay, but we have minus, but we already have d. Okay, we have dv. If you integrate, you will get v. Okay, let's go ahead and integrate this one. If e power negative t divided by negative 1, so you will get this one back, e power negative t again, and then multiply by du. Du is just 1, so that's going to be just multiplied by 1, so we will have plus 1. So this is going to be the integration of this one. So we can write here, if you integrate this whole thing, this is what we are doing right now, this whole thing, we will get this result, minus t plus 1 e power negative t minus e power negative t plus, this is constant. Okay, now we have to put constant in this side. Now after we figure out everything, now our final answer should be in terms of y, so we have to divide everything by e power negative t in order to get rid of this e power negative t in this side. So here we divide by e power negative t, and this one also will be divided by e power negative t. Now if you divide this one by e power negative t, that's going to be just y, and in the other side we have, this is going to cancel with this one, so we will have minus t plus 1 minus t. Also we can multiply this minus both, so this is going to be minus t minus 1, and here we will cancel these two, so we will get minus 1 here, and plus c over e power negative t, or we can write it as c times e power t, because if we bring this one to the numerator, that's going to become positive. So finally we can write our answer as y is equal to minus t minus 2, because minus 1 minus 2, plus c e power t. So this is going to be the general solution of this differential equation, and that's how we do this kind of problems. I hope this helps. Thanks for watching. Don't forget to subscribe. See you next time.